All right, so let's look at 4 different levels of measurement. The way that a set of data is measured, okay, is called its level. Correct statistical procedures depend on whether or not you understand that level of measurement. Not every statistical operation can be used with every set of data. Data can be classified into 4 different levels. Nominal is for categorical variables or qualitative variables where order does not matter. Let's take a look down at the example and see which ones of these might be nominal, scale, level. The type of car you drive is a qualitative data measurement, and order does not matter when we actually organize this data. The type of calculator that you use is also nominal. Whether we have a TI-83, 84, Inspire, it doesn't really matter the order in which we put that on a graphical display, if you will. Now, the next level is ordinal. This is still categorical and qualitative, but in this case, order does matter. Now, if you did feel like it made sense to put the release year and then put those calculators in order that way, it gets a little bit tricky with this type of calculator if that's a decision that you would like to make. So if it makes sense, you could maybe say that the type of calculator you use is ordinal if you want to categorize that by how old the calculator is. Okay. However, type of car you drive, if you do a Honda, a Toyota, a Ford, a Chevy, that's really not going to change the order. Another example that is not here that I want to give you is what's called a Likert scale. Many times we use an ordinal scale variable that goes from strongly disagree to strongly agree or vice versa. In that case, it does absolutely make sense to have those data values, okay, that variable and those data values in a certain order, even though it is still a proportional type question or qualitative type question. An interval scale is quantitative, but what makes interval scale really kind of tricky is 0, the value of 0 does not mean in absence of. 0 is just a placeholder in measurement. For example, if you're thinking about temperature, you can have 0 degrees Fahrenheit, but it doesn't mean it's absence of heat. It just means the heat is colder than, there we go, absence of heat, it is colder than maybe 30 degrees Fahrenheit. So it is a relative measurement. It's a placeholder in measurement, but it doesn't necessarily mean absence of temperature. And you're like, well, 0 is really, really cold. there is still a heat component to that. Like 0 is still warmer than -10 degrees Fahrenheit. So it's just a relative placeholder. Another way we can think about interval scale variables is when you're talking about the numeric year. So like 0 AD versus 2023 AD. Again, 0 doesn't mean like absence of years, it's just a placeholder. Temperature and year are kind of our two big interval scale variables. Okay, there are other ones, and we'll talk about those in class together. Okay, but I want you just to know that's what that means. All right, ratio scale is all other quantitative variables. It means that you can actually measure it, and 0 means in absence of. For example, in part A, if you have 0, then you have no shoes. That is a ratio scale variable. If the distance to your home to the nearest grocery store is 0, you must live in a grocery store, okay? But your distance, 0 means something, and that's a ratio. The number of classes you take per school year, also a ratio. Scale level. Weight, yeah, if you have 0 weight, that would mean in absence of. And number of correct scores is also ratio because 0 means that you did not get any correct. Again, in class, let's talk about IQ scores together, and I really want you to think about, does 0 mean absence of IQ?